So now let's continue here. We are gonna implement the call get. Okay, so this will return the element that is in the index. So first we need to see if there is the element there. So if not, we're gonna return an error. So let's put the error code as AE, no error. First, if index is greater than, well, LV elements -1, or index less than 0, so it's an invalid index. Not invalid index. Oh, I am a little bit tired maybe. So if the index is more than elements +1 and so I will change the error to be equal error to be equal AE index out of bound exception and return no. Okay, whoops, no. Okay, and if it's okay, I will return the gal LV list and the position of index. That's it. Let's continue. Now gal index of. Okay, so this will return the index of the first occurrence of the element, or -1 if does not contain the element. So for int I equals 0, I less than gal LV elements I plus plus, so we are gonna iterate here. So if gal LV list in the position of I is equal we, so the object or the element is there, so return I. Okay, if we finished looking for it with all elements, so we search in all elements and we didn't find it, so return -1. Good. Let's continue. Return true if the list contains no element. Okay, so if gal LV elements equals 0, we will return true, or else return false. Well, this we can change a little bit to get it not easier to understand, because this situation that I put here, I guess in my opinion, is the easiest to understand. But you can just do this: return gal LV elements equals 0. If you think it's good to have the parentheses here to get it cleared, and this you just put out. That's a way to do this. But in my opinion, this is for the beginners a little bit difficult to understand. That's why I first put in that way. But it's okay. We can. I guess it's not so difficult. You can understand. Okay. The next one, gal last index of. Oh, it's in. Let me see if I can refactor, rename, last index of. Okay, so let's code it. So int I equal to go lv elements -1 -1. Okay, so 4. I can just put nothing here. I could put this in the 4, but I need it because if I came to the last one, I will have -1. I will return -1 when the 4 finished. So it's faster, let's say, or at least the CPU doesn't need to have a comparison and so on. So I plus equals 0, I minus minus. Okay, if go lv list I equal to the element break, return I. This is another way of doing that. So I initialize the variable with the total elements, and if I could find it, I have a break. The break will kill the 4, and I will return the I, the index of the element. If I couldn't find when we finish it, it will be -1. So it will return -1. It's another way of doing that. That's why I have, when I try to find the index of and the last index of it are different. So to show you that there are two ways of doing that. So now the remove by index. So let's try to do it. If index more it's greater than go lv elements -1, or index is less than 0, so it's invalid, I would just return. I don't need to tell anything. For int I equal index I less than go lv elements -1. I plus plus. So I'll iterate in all elements of my list. So go lv list I is equal to go lv list I plus 1. Okay, I will finish the code first, then I will explain to you. Go lv elements minus minus, oops, go lv elements, go lv list go lv elements equal to no. Okay, so I'll try to explain to you. We're going to remove the element that's in this index. So for example, the index is 2, so number 0 and 1 will remain. The 2 I will remove, and imagine that I have 5 elements. The 3, the 4, and the index 4, so if I have 5 elements, need to be copied to the position 3, and so on. If I have 10 elements, for example, and I need to remove the index 3, so I will jump index 0, 1, and 2. That's why we start in index, and from 3 on we will copy the 4 the index 4 to the index 3, the index 5 to index 4, and so on. Then we need to say that we have one element less, and the last element of my physical list, I will put null there, so that there's no way that we will have the element in the list. Of course, that as I'm removing one element here, I will never get to this place again because of the algorithm. But it's a good idea to put null there, so that it's if you see in the debug, you'll see that we don't have any null, any elements that's not null that I don't have. For example, if I didn't put anything in the position, I have null. That's the idea. I hope you understand. If you understood, the goal will be okay. So now I will remove the element. So I will do this. Pay attention. Int index equal to gal index of the element. So I will reuse code. The gal index of will return the index of this element to me. So if index equals to -1, that means that I didn't find it. So return, just ignore it. Or gal remove by index the index that I have it. So this will use other functions that I've already coded here. Good. So now the gal set. Let's do it. First, let's see if the index is valid. So if it's less than 0 or index greater or equal to gal lv elements. Okay. What? This is an error, so return a index out of bounds exception. Good. If the index is okay, so gal lv list index equal e, and return e, no error. That's it. The gal size, it's very easy. I just need to return the gal lv elements, just that. The gal sort, this is a little bit tricky because I will receive a function, a callback function, to determine who is greater than the other one. So I will call this function to see if the first element is greater than the second element, and then I will do the sort. I'm using this for the sake of simplicity, the bubble sort, that is easier to understand, but you can change it with any sort that you want. Okay, so if gal lv elements are greater than 1, because if I have only one element, doesn't need to sort. So void aux equal to null. So I have a void pointer here just to work with the elements that I need to sort. The bubble sort, the idea is every time that one is greater than the one, I swap it. So to do the swap, I need the aux. So for int I equals 0, I less than gal lv elements minus 1 I plus plus, another for int j equal to I plus 1, j is less than gal lv elements j plus plus. If you don't know this algorithm here, the bubble sort, tell me in the comments that I will explain, or we can start looking at some sort algorithms if you want. So now I will use the callback function. If sort gal lv list I will pass this the element in the I position, and I will pass the element lv list with a j position, and this sort needs to return true if the first element is greater than the second element, and so on. So as it is generic, I don't know how to sort it, and this is the key element to do the sort. So I need to provide to the API the way that I want to sort. Just like let's say Java, JavaScript, and Dart, and other languages that you can use callbacks, callback functions, and so on. Is that the same idea? So the aux will receive the gal lv list I. The gal lv list I will receive the gal lv list j, and the gal lv list j will receive the auxiliary, and that's it. Only this. Now define is the same idea. I need to know how to find an element, so I need a callback function that knows how to compare the element that is in the list with the element that I want to find, and the element that I want to find. So what to find and defined here. So the idea is the same. So let's do it. For int I equal to 0, I less than gal lv list, gal lv elements I plus plus, and then if find gal lv list I, so the element that's in the list, if it's the same as what, good. Now I will return gal lv list I. That's it. And internally, these functions know how to do this. This maybe could be a structure here and a string here. So we'll find the string in the structure. So the find has to know how to do it. I don't need, I just need to use the API. If this is equal this, it will return true for me. That's the idea. So if I finish the for, not finding, so return no. Good. And the last one, gal trim to size. What's the idea? I will create another list, and I will just copy the elements that are valid, and I will trim it. So physically will be trimmed. So let's do it. Void temp equal to null. This will receive the new list. So temp equal to malloc the gal lv elements. So the size now will be just the elements that are in the list, times size of void pointers. Okay, this will allocate the memory. If not temp, return, just return. If I don't have memory, no way. Gal lv initialize elements of the temp list, and this size will be gal lv elements. Okay, so now for size t I equal to 0, I less than gal lv elements I plus plus. So temp I will be equal to gal lv list I will copy all the elements, the valid elements. Then I will free the gal lv list. The gal lv list will be equal to temp, so I will free memory, I will copy, and the gal lv size now, it will be the same as gal lv elements. Okay, if you notice, I don't know, sometimes I use size t, sometimes I use int. This is in purpose so that you can see that size t is almost the same as integer. The idea of the size t is to use in this kind of situations. Many times, like here, it's preferable to use the size t. You should indeed, but I use int here and I use size t here, so that you can see that you can use it in this situation as the same. But you need to know, in int variables I could have a minus value, so -1, -10, and so on. But in size t, no, because I don't have signs. Okay, so is unsigned the variable I here. It's unsigned int. Okay, so that's it. Now we need to go to the main.c to code it. Let's open it. And now I will need the standard IO. I will need include the standard lib. Okay. Include string, and of course I will include my generic array list. Okay, I will put here some comments. So this is a complex test of the generic array list. We will have a simple CRUD in memory to see if it will work. Okay. In this test, we will create a structure to hold ID, name, address, and phone number. Okay. Then a menu to add, find, remove, sort, and list the data. That's it. Okay, so now I will start with some constants for the menu. Menu constants. Okay, I will use an enumeration. Enumeration, menu, enumeration. Now let's start. Option unselected will be 0. Okay. Option add, option find, option remove, option sort, option list, and option quit. Good. These are the options of the menu. So now the structure. So struct data. I will have an ID that's integer, char name 101, char address 251, char phone 101. It's too big, but no problem, it's just a test. The idea here is to use big things to put there to see if it works. Okay, so now I will have some prototypes. Okay, so the first one, this function is used to find data. Remember the callback function? So let's put it here. So it will be a boolean find element void pointer where I want to look for, void what I want to find. Good. Oh, I need not, I put here standard leave no standard bool. Sorry for this error, and it's written wrong. Okay, this is the find function. Now another one that I have to code. This function is used to sort the data by name. So boolean sort order void a, void pointer a, void pointer b. Okay, the name of the elements, you can put anything you want, no problem. Now another one, this function shows and lets the user choose its option. Shows the menu. Good, let me change it here. Its option. Okay. Oh, its option. So now int menu. Okay, it will return an int. And another one, just one more. This function creates a new structure. I'll pass the values to the function, and it will return to me a pointer for the structure. So struct data new data int id char name, a pointer to a string name, a pointer to a string address, and a pointer to a string phone. That's it. So let's start with the main. Okay. First, we need to initialize our structure. So call initialize. I need the size of 5 and the increments of 5. I could put it any value that I want. Int option, I'll create a variable for the menu. Be unselected. I need a pointer to data. Struct data working data. Create a variable for the ID. Char name. There's some variables just to work with the data when the user types and so on. Then what we put in the structure, and it goes on. Char address 251. Char phone 101, and a variable for the error. Okay. So now let's start the loop here of the menu. If while option is not equal to the option quit, option is equal to menu, I will call the menu, switch option. Okay, we will code the menu so that you can see what we are doing here. So let's come here, int menu, it's not difficult, int op equal to op unselected. I'll create just a variable so that the user could type, and it will use here for the user to type and return to the main function. So now let's have some prints here. Print very simple. Menu, printf, %d add, this way is very interesting, because if I include something in the menu, I don't have to bother with what is the value of the option add, because it will be positional in the enumeration here. So that's why I like to use like this. So the other one is find, remove, sort, list, and quit. That's it. So now printf choose your option. Scanf %d upper change op. Okay, I will read this variable, and I will clean up the buffer so that I don't have problems with garbage in the buffer, and return op. Let's get back to my here to the switch. Okay, now I will go to all the options of the menu. So first here, case add. What do I have to do? So printf type the ID. Okay, scanf %d. I will read here the ID. Okay, good. And every time that I read anything, indeed, prior to strings and char, we need to deal with the garbage in the buffer. So it's a good idea just to clean the buffer. So printf type the name. Okay. fgetS the variable name 100 characters from the standard input. Good. It's ideal to use the fgetS instead of using scanf to read, let's say, strings, because the scanf, it's difficult for you to read more than one word in a string, because every time that I have a space between the words, I'll have the problem. It's very ugly the way that scanf will deal with that. There is a way, but it's very ugly. So I prefer to use fgetS. But I have a problem. fgetS puts everything in the buffer inside a variable, so the enter will be there. So how to deal with that? So I will have to do this. I will get the name. The name is a string, so I can deal with it just like an array. So I will try to find the enter and put in that position a end of string there. But how to find it? I will use a function here, strcspan, that have two parameters. The first one is the variable that I want to find, so it's the same as the name variable, and the other parameter is a string that has all the characters that you need to find. So if any of these characters inside this string are in the first string, it will give you the index of that. So you can have many characters there, there's no problem, but the first occurrence of one of them, it will return you the index. In our case, we just need the enter. So it will look for the enter in this variable. It will return the index, and we are going to put an end of the string when it finds an enter. So that's the idea here. Okay, so I will do the same for that I'm doing for the name. For the address, so type the address address here, the size is 250, so address, okay, and do the same for the phone number. So type the phone number. Okay, so here is the phone that it's 100, the same phone and phone. Okay, so the user typed everything. Now what do I have to do? So I will come here, working data is equal to new data. I will pass the ID, the name, the address, and the phone to the function. It will alloc memory, put everything in there, and will return for me a pointer to that. Then I will have the gal add. Oops, what do I do? Oh, no, one L only. Gal add the working data. Okay, and will be added to the list. So now the option to find it, case option find, printf. It's the same as the other one, so I will just copy here. So the user will type the name and working data will be equal to gal find the callback function, gal find element. You see that I just put the name of it because it will be a pointer to the function and not the calling the function, and what I want to find it there. Okay, so if working data equal to new, I will print register not found. Okay, so I couldn't find the register in the list. Else printf I will go to the next line, found, and I will print out everything that I have here. So printf name so I'll print the string working data name. Okay, then the address, very nice. Phone, okay, and that's it. So now let's see the find element here, how to code it. So I will come right here. So here boolean find element void where to find it, void what to find. Okay, so I need to use some variables inside of it because it's a callback function. I really don't know if there is another way to avoid doing what I'm doing here, but pay attention. Struct data a char name. Okay, so I'll create two variables inside of it, and then I need to do that. A equal where name equals to what? I tried different ways of doing that, but I couldn't. So this way I know that it will function very well. So return not str compare string compare a name. Okay, so I will compare the name, that what I want to find, for the name of the where, the structure. So the structured data, they have name there. So I will compare the two names. Why do I doing this not? Because if I return, if I find it, it will return 0, and 0 is false. So that's why I'm negating the false, so that I have a true here. And if we couldn't find and return any other value, that is true, and I will negate it and it will be false. That's why I did this. Okay, so the find is ready. Now let's work in the remove. Case option remove. So let's do it. So I'll do the same here, type the name and so on. Working data is equal to gal find, so it will try to find the element there is the same here. Okay, so first we're going to try to find, as the find element function, the name that I want to find. Okay, if working data equal to null, so if the working data is equals to null, printf register not found. Good. Else go remove the element working data. So if the goal find could find the element, it will be removed. Very nice. Only this. Now case, another option of the menu. Okay, sort. So we'll call goal sort, and we'll pass the sort order function that I will show you how to code it right now. Okay, so now let's see here. Boolean sort order void A void B. Okay, so the same struct data A1 struct data pointer B1. A1 is equal to A, B1 is equal to B. If I will compare the two strings, A1 name, B1 name, so it will return 0 if they are equal, so I could just negate that. So they are return 0 if they are different. Yes? No, that's the idea. If they are equal, it returns 0. 0 is false, then I turn it to true. So return true. Or else return false. So it will be sorted. Very nice. Now the other option, case option list for size d I equals 0, I less than gal size I plus plus. Notice that I'm using the API to do this. So working data is equal to gal get I. I will pass the variable to see the error. Okay, but we will ignore the error just because it's just a test. I guess it's something very interesting to do now that we are developing it, but in real world in production you need to check the errors. Okay, so printf, a bunch of minus sign here, printf id percentage d backslash n working data id name. So here is a string, the address, and the phone number. Let me put less dot signs here, just align them in the phone. Okay, and break. Okay, so it will list everything. Case option quit, I will do nothing. So I'm gonna ask me, hey Marcos, why are you putting the quit here? Because all the valid options will be there, and quit is a valid option because I use the default, and in the default I'll just print out invalid option. That's why. Okay, good. So that's the code here. So when I quit, I just have to do one thing: go destroy to free the memory. Very nice. So now let's try to run it to see if it works. So let's run. Oops, I have a mistake here. The data. Oh, I didn't code the new data. I'm getting crazy. Struct data pointer new. Whoops. New data int id char name char address char phone. Okay, so first we need to create a new a new pointer here to allocate. We need to allocate memory for the new pointer. So struct data pointer new is equal to malloc size of struct data. Okay, so we need to import here another one, include std standard lib. Okay, and now let's continue. Great. If not new, print f no memory. Okay, exit failure. Good. If everything is okay, so new id will be equal to id, string copy new name, copy the name to the structure, copy to the structure the new address, so we'll copy address to the new address, string copy new phone to phone. Okay, and return new. Good. Now I guess it will work. Aha. Great. So first let's add at least 3 items here. So 1. The ID will be 1. Whatever. Name. No, let me get one that Washington. Okay. The address. First street. The phone 123. Whatever. Okay. I will add another one. ID 2. Adrian. The address, Main Street, and the phone 456. Good. Now add another one. Okay, the ID is 3, name Marcos, address Brazil, phone 789. Okay. Now, if I list, let me see. We have Washington, Adrian, and Marcos. Good. Let's try to find Adrian, ID 2. Okay, so 2. Adrian. Okay, Adrian, Main Street 456. Let's see here, Adrian, Main Street 456. Okay. Now, let's sort first. So, sort. Okay, 5. List. Oops. Sort function is not working. Let me see. Yes, I type option 4. The sort's not working. Let's see first. But first, let me try to remove something. Remove Adrian. And then we go to sort. 3. Adrian. Okay. 5. List. Okay, Washington and Marcos. Good. Only sort is not working. So let's see why. Let me check first the code, if it's okay or not. So first, sort. If not, oh, no. Here is the error. If this is greater than 0, it's not equal. If this one goes after this, then you have the true. Good. Okay, so now let's add again and run it. So I will add 1 Washington 1, 2, 3. Oh, okay, you get it. So 1, 2, 3. Let's add Adrian. Oh, ID 2, Adrian, First Street, 4, 5, 6. Okay, let's add Marcos. Oops, ID 3, Marcos, address Brazil, phone 789. Okay, so list we have here Washington, Adrian, and Marcos. So good. Now let's sort 4. Let's list 5. Okay, first one is Adrian, then Marcos, then Washington. Very nice. And 6 will clean all the memory and so on. Okay, so that's it. If you like it, don't forget to give me a thumbs up. Don't forget to subscribe to the channel, please. This channel is gonna have only this kind of code, not easy stuff. And we will do something very interesting, okay? In the next video, we will start to code a basic language interpreter. So it will be very interesting the way we are gonna do. The idea is to create a retro basic. So you could choose the flavor of basic, if it's TRS-80 basic or Microsoft basic or whatever, ZX1 or ZX Spectrum basic, Sinclair basic, whatever. So that's the Commodore basic. I know that many people that speak English, they know Commodore and Commodore 64. We're gonna try to use the idea is not to create Commodore 64, for example, virtual machine. No, it's not the idea. It's only the basic language, how it works and so on. And if you have time, we can add MSX basic too, because it's interesting in many people in Brazil, Europe, and in Japan they use it. Okay, so that's it. See you and keep coding.